Welcome everybody to the third unit of Pre-Calculus 11. So today we're going to be looking at trigonometry, and in this unit we only have 3 lessons that we're going to do, and we're going to start with the review lesson. So we're going to review right angle trigonometry. So you did a lot of this in grade 10, hopefully. So the right angle trigonometry, you might remember it just with the acronym SOHCAHTOA. Oh, good. Dropped my pen. Good start to this video already. SOHCAHTOA. So let's just do a quick review on how to use SOHCAHTOA. So SOHCAHTOA is just 3 different ratios in a right triangle. So first of all, let's talk about, if it'll let me scroll. Scrolling is not working. Computer is frozen. Hopefully you can still hear me. Oh, there we go. There we go. A right angle triangle is a triangle where we have a right angle. So you can see in these 3 triangles, we have a right angle signified by that little square, or indicated by that little square. And we know in a triangle we have 3 sides, and we have 3 angles. So in the first one we have the hypotenuse side, the adjacent side, and the opposite side. Those are our 3 sides. And the 3 angles will be angle A here, the right angle, and the third angle in the top there. So I think you did Pythagorean theorem in grade 9. So if we go to the far right here, this is grade 9 review. And Pythagorean theorem is an equation or a theory that helps you, if you have 2 sides of a triangle, you can find the third side. And when you're doing this, you want to label your sides of the triangle with A, B, and C. The only important one that you get correct is C. C always has to be the longest side of the triangle. Or if it's hard to tell, the side across from the right angle. The other ones, A and B, can actually flip-flop. When you label them, the equation will work out the same every time. And the equation for that is A squared plus B squared equals C squared. So if you're looking to solve for A instead of C, it would become A squared is equal to C squared minus B squared. And you can get that from the initial one just using some algebra. And then the same thing for B squared. B squared is equal to C squared minus A squared. And then in grade 10, you started looking at the trig ratios. So that was our sine, cos, and tan functions. And these really depend on what your reference angle is. So if you look in the on the left side here, we're going to deal with angle A. You can see it's indicated by that little angle sign in the corner. So from A, one of the biggest things I teach my grade 10s is label your triangle every time. So if your angle A is the one that you're using, your reference angle, the side opposite of it is the opposite. The hypotenuse is always the longest side, which is across from the right angle. And the adjacent is always the side that connects the reference angle to the right angle. Once you have those labeled, then you can figure out which sine ratio you want to use. So we use the acronym SOHCAHTOA. SOHCAHTOA to figure out which ratio we want to use. And you can see that they tell you right here that the sine ratio, so over here sine is SOH, the sine of the angle A is equal to the opposite over the hypotenuse. And then we look at the cos ratio, and that's adjacent over hypotenuse, A over H, so cos is equal to adjacent over hypotenuse. And lastly, the tan ratio is opposite over adjacent. So tan is opposite over adjacent. And what you notice about that is every ratio is unique, right? There's 3 different sides on our triangle, and every ratio here uses a different set of them. So sine uses opposite and hypotenuse, cos uses hypotenuse, but it switches out the opposite for the adjacent. And then tan uses the opposite in the adjacent and doesn't use the hypotenuse. So whatever 2 sides you know or know and are looking for, you can choose a ratio that's appropriate. And then if you see in this next triangle, they move the reference angle to the top. So now we're dealing with angle B, and the ratios stay the same. Sine is always opposite over hypotenuse. Cos is always adjacent over hypotenuse. And tan is always opposite over adjacent. But where those sides are on the triangle change based off the reference angle. And you can see that from B, now the opposite side is the bottom half, whereas before, or the bottom side, whereas before it was the adjacent was in the bottom, or was the bottom of the triangle. And the hypotenuse always stays the same. It's always the one across from the right angle or the longest side. And now our adjacent, instead of being the bottom of the triangle, is the right side right here, because it's the side that connects the reference angle and the right angle. Hopefully this is all ringing a bell. We are going to do some practice problems, so hopefully it will refresh your brain a little bit. So let's move on. This is going to be a little bit of a longer video. I apologize. I'll do my best. So it says here, consider the following triangle. Here's our triangle right here. Use the Pythagorean theorem to calculate the length ST. So the length they're wanting us to calculate is between S and T. And you can see it's the one where we don't have a number. So the first thing you want to do is label your triangle. Pythagorean theorem means we're going to label it with A, B, and C. And the only one you need to get correct is C. C has to be the longest side or the one across from the right angle. So that means C is equal to 25. And then we can just say A is 7 and B we don't know. So we can use our Pythagorean theorem formula, and it's going to be C squared is equal to A squared plus B squared. But we are looking for B, so we can subtract A squared from both sides. And what we're left with is B squared is equal to C squared minus A squared. And now we can just fill in our values, right? We know B squared is equal to, C is 25, so 25 squared, minus A is 7, minus 7 squared. So we know B squared is going to equal 25 squared is what, 625? 625 minus 7 squared is 49. So now we know that B squared is equal to 625 minus 49 gives us 576. But we don't really care what B squared is. We want to know what B is. So we can use our square root to get rid of the square. And that gives us the answer of B is equal to 24. So that means this side is 24. So before you go any further, you want to ask yourself, does this make sense? Is this a good answer? And the only thing that you should check is these sides A and B should be shorter than your hypotenuse. Your hypotenuse should always be the longest side. In this case, B is close, but not longer, so it's good. It's probably a correct answer. Just make sure you're not the student who writes, oh, B is 48 or 576, I did it, and then not do that check of, does this make sense, right? You should always ask yourself at the end of a math problem, does this answer make sense? And if you feel confident and it seems to make sense, then move on. But a lot of times, if you take that extra second to ask yourself, does this make sense? You'll get that gut instinct of, wait a second, why is it 576 when the other sides of my triangle are 25 and 7? Something doesn't add up here. And then you can go back and check your math. So state as rational numbers the values of the following trigonomic ratios. So you can see the top row here is using r as the reference angle. So that means we're using r as the reference angle. Maybe I will use green here. So I'm going to erase this stuff because now we're using the trigonomic functions. I'll leave 24 because we need to know that. But if r is our reference angle, that means 24 is our opposite, and 25 is the hypotenuse. C is always the hypotenuse, and that leaves 7 to be the adjacent. So sine of r, we know sine from SOHCAHTOA is opposite over hypotenuse. So in this case, our opposite is 24, and hypotenuse is 25. We know cos is adjacent over hypotenuse. So we can use those numbers. We know the adjacent in this triangle is 7 over 25, and tan is opposite over adjacent. So in this case, opposite is 24, sorry. Opposite is 24, and the adjacent is 7. So those are the trigonomic ratios if we're using r as the reference angle. But you can see in the next row, we switch it to s, which is fine. We can totally do this. So s is this angle up here, which changes now our sides because this now becomes the opposite. And the hypotenuse stays the same. And this one over here becomes our adjacent. So you can see we've swapped the opposite and the adjacent. So that is no longer our adjacent. That is no longer our opposite. So now if we're doing sine of s, it's going to be the opposite, which is 7 over the hypotenuse, which is 25. The cosine of s is the adjacent over the hypotenuse, which is 24 over 25. And the tan ratio is opposite over adjacent, which is 7 over 24. So now we have all of the trig ratios done for this triangle. You can't really do trig ratios for the 90-degree angle because the opposite and the hypotenuse would be the same number and it just wouldn't work. So it says here, comment on any relationship you see from your answers. Well, we can see that sine of r actually equals cos of s. You can see that they're both 24 over 25. And same with sine s is equal to cos of r, which is cool. And then the last one is that the tan ratios are reciprocals. So one of them is 24 over 7. The other one is 7 over 24. Reciprocal. This is a pretty quick review, so I think it would be good to spend some time looking over your Math 10 stuff if you have a chance. So now we're going to use these ratios to start calculating values. This is the reason that we use these, is so that we can calculate some values. So in this case, we're going to look at calculating angles. So using SOHCAHTOA, we can calculate angles and we can calculate side lengths. And there's a little bit of a different process for each of them. So here they give us a triangle. We have 6 centimeters on one side, 5 centimeters on the other, and this angle x here. So without even knowing what the question says, I can see that I have 2 pieces of information, 2 side lengths, and an unknown, which is this angle. So that unknown angle becomes our reference angle, and we can label our sides from that. We know the side across from our reference angle is the opposite, and we know the side that connects our reference angle and the right angle is the adjacent. So if we wanted to solve for that angle, we have to look at our SOHCAHTOA and figure out which of those ratios has the opposite in it and the adjacent in it, because we don't know the hypotenuse. We could solve for it using Pythag, but there's no point. We already have two of them, and we have a ratio. We have our ratio somewhere that uses those two, because all of our ratios have every combination, or our ratios contain every combination. So we have opposite and adjacent. Opposite and adjacent. We go up to our ratios. We have to find one of them that uses opposite and adjacent, and you can see right here, the tan ratio uses the opposite and the adjacent. So you can set this up as, they've got it right here, but I'm going to write it because I like to do it myself. Tan of our angle. So this part always represents the angle, and we don't know the angle right now, is equal to our opposite, which is 6, over the adjacent, which is 5. Awesome. So every ratio has 3 pieces of information in it, right? We have an angle and we have 2 side lengths. And you need to know 2 of those pieces of information in order to find a third. So here we're looking for an angle. We have both side lengths. So you can, when you're looking for an angle, we always use the inverse functions. So you want to use second tan in your calculator, or second function tan. Second function tan. What happens when you click that button is you get, so we're trying to find x. So you click second function in your calculator and you're going to get tan to the -1. That -1 indicates that you're dealing with the inverse tan, and then a bracket, and then you can go 6 divided by 5 bracket. And when you click enter, it should pop out with your answer. And the answer looks like it's going to be inverse tan of 6 over 5 is 50. So it looks like the angle x is 50 degrees. The process they've done here, just on the side, is they actually found what the value of 6 over 5 is. 6 divided by 5 is equal to 1.2. And then they did their inverse tan, or second tan function, of 1.2, which is the same thing as doing it inverse tan of 6 over 5. And you get 50. So if your calculator is giving you a weird number, double check that you are in degrees. If you're not in degrees for our trig unit, things aren't going to work. The other things you might see are radians or rad, or gradients or grad. We don't want to use those. We want to be using degrees. So let's do a problem. It says here, a telephone pole is 12 meters high and is supported by a wire 14 meters long, fixed to the top of the pole and to the ground. The hardest part of these problems is drawing them, I think. This is where most issues come from, is students not drawing and labeling a picture properly. And they do all the math properly, but because they put one of the sides on, or labeled one of the sides wrong, you get the incorrect answer. So telephone pole, we know, is straight up and down. The best part of right angle trig is that when you're drawing these problems, you know you're probably dealing with a right angle triangle. So we have a telephone pole that is 12 meters tall, and it's supported by a wire fixed to the top of the pole and to the ground. So our wire probably does something like that, and it is 14 meters long. And then we have some ground in between. Draw a sketch to illustrate the information and calculate to the nearest degree the angle between the wire and the ground. So the wire and the ground make an angle right there. So we'll label that X. So from here, the first thing we want to do is label our triangle with our opposite, adjacent, and hypotenuse. So across from our reference angle is our opposite. And the longest side, or the side across from the right angle, is the hypotenuse. So we're dealing with the opposite and the hypotenuse. And if you look at your SOHCAHTOA ratios, the one that you're going to use is opposite and hypotenuse is your sine. So we can write that down. Sine of X is opposite over hypotenuse. And I always encourage people to actually write the formula out, because a lot of times the opposite and the hypotenuse will get switched or something, and your calculation isn't going to work out. So we write out the general form of the equation and then fill in the values that you know. So we have sine of, well, we don't know X, so we'll leave it. X degrees is equal to, our opposite is 12 over the hypotenuse, which is 14. And we're looking for an angle. We want to use that's supposed to be a star, the inverse functions. So that means that we're trying to solve for X. And to get X out of the sine function, we have to use inverse sine of 12 over 14 of our ratio. And when we do that, we get 59 degrees. That is solving for an angle. That'll work whether you're solving for the top angle or the lower angle, whether you're using sine, cos, or tan. That is the same process every time. Now we're going to use trig to calculate sides or side lengths. So here, they're giving us a triangle, and you can see in triangle A, B, and C, we know this angle right here. We know that that angle is 49 degrees, which is awesome. So from this angle, I can label my triangle. This is my opposite. This is my adjacent. And this is the hypotenuse. That's terrible, messy writing. So you can see we know, what do we know? We know this angle, we know this side, and we're trying to find that value. So we need to know two pieces of information to find a third. So it looks like we know the hypotenuse and are looking for the opposite. So if we're looking at SOHCAHTOA, the ratio that is opposite and hypotenuse is the sine ratio. So we can write our general form of our equation. Sine of X is equal to opposite over hypotenuse. And then we can fill in the information that we know. We know the angle is 49, so that actually goes into those brackets right here. And then we don't know the opposite. We'll leave it as X. And we know the hypotenuse is 17.6. So we can do a little bit of algebra. So to get X by itself, we're going to multiply both sides by 17.6. And then that cancels out on that side, and we're left with 17.6 multiplied by sine 49 is equal to X. So in this case, we're not using the inverse function. So in your calculator, you would just put in 17.6 multiplied sine 49. And it will spit out your answer, which is 13.3. So that means that opposite side, side BC, is 13.3. When it comes to calculating sides, there's two processes. There's this one that we just did, where our unknown was in the top of the fraction in the ratio, and then there's going to be one where the unknown is in the bottom of the fraction. So you can see here, if this is our triangle, we know angle R, which is 73. So we can label our triangle. This is the opposite. This is the adjacent. And this is the hypotenuse. So from here, we know the angle, we know the adjacent, and we're looking for the hypotenuse. So if you go to SOHCAHTOA, you can say adjacent and hypotenuse, that's a cos ratio. So now we can write our cos of x is equal to adjacent over hypotenuse. Then we can fill in the values that we know. We know the angle is 73. We know the adjacent is 24. So we get a formula that looks like this. And so now this one's one extra step of algebra, which is totally doable, but you want to get a by itself, and you want to get a in the top of the formula, right? It's no good to us. We're not trying to solve for 1 over a. We want to solve for a. So what you can do is multiply both sides by a. A over a cancels, and we're left with a multiplied by cos of 73 is equal to 24. A is still not by itself, so we want to get it by itself. We can actually divide out the entire cos function from both sides. And then what you're left with is a, because over here this cancels, right? So what you're left with is a is equal to 24 divided by cos of 73. So now you can just type that into your calculator. 24 divided by cos 73. Make sure you're in degrees. And when you do that, you get 82.1. So that means the side A that we're looking for is 82.1. And that answer seems to make sense. It's larger than the adjacent. I forgot to do that. Does this make sense on the last question? But it also made sense. So the side QR is 82.1. So it says use trigonometric ratios to determine the side lengths of AB and AC in the given example. Okay, so I'm going to say that this will be side X and side Y. We're looking for both of those sides. The first thing I want to do is label my triangle. This is my known angle. So that means X is the opposite. Y is the hypotenuse. And 109 is the adjacent. So we know an angle, we know the adjacent, and let's start by looking for the opposite. So adjacent and opposite, if you're ever unsure, write SOHCAHTOA down at the top of your page every time. It's a really good habit to be in. It'll help avoid any little mistakes. So adjacent and opposite, you can see is the tangent ratio. So you can say tan of our angle. Maybe we should write it in general form. I've been preaching that. Tan of theta. Theta is just a Greek letter used to represent an angle, like a variable, is equal to opposite over adjacent. So now we can plug in the values that we know. Tan of 74 is equal to the opposite, which we don't know, over the adjacent, which is 109. So to solve for x, we want to multiply both sides by 109. Cancels on this side. I'm left with x is equal to 109 multiplied by tan of 74. And if I type that in my calculator, I should get 380. And the adjacent was in feet, so this should also be in feet. 300. Erase. Haha. 380 feet. Now we want to find the hypotenuse. We know the opposite and the adjacent now. I would recommend, if you can get away with using information they already give you in the question, then do that, right? We also know the opposite, but we calculated that number. And if there was a mistake in our calculation for this number and we use it to calculate the hypotenuse, then we're going to get that one wrong as well. So I would suggest, if you can help it, using just the information the question gives you to calculate this one. And we totally can, because we know an angle, we know the adjacent, and we're looking for the hypotenuse. So the ratio we're going to use is the cosine, adjacent and hypotenuse. So we know cos of theta is equal to adjacent over hypotenuse. We can fill in the values we know. Cos of 74 is equal to adjacent, which is 109, over hypotenuse, which we'll say is y. So now I need to do a couple steps of algebra to solve for y. I'm going to multiply both sides by y so that they cancel out on this side. Now I'm left with y multiplied by cos of 74 is equal to 109, and I can divide both sides by cos of 74. Cancels on this side. So now I have y is equal to 109 divided by cos of 74. And when I type that in my calculator, I get 395 feet, which means my hypotenuse is 395 feet. Does this make sense? Yep, the hypotenuse is longer than the opposite and the adjacent. It all makes sense. Seems to be right. And that's it. That's calculating side lengths and angles using our SOHCAHTOA, or our trigonomic functions. Thanks for watching. If you want extra practice, there is a class example number 4 on the next page. It's got a lot of good questions, so it might be a good one to start with. And thanks for watching. Talk to you guys later.